Now let's study colloids. What are colloids? Colloids are actually heterogeneous mixtures. Colloidal state is the state between solution and suspension. You can compare the size of particles. In solution, size of particles is 0.1 nanometer to 2 nanometer. In colloidal state, the size is 2 nanometer to 500 nanometer, and in suspension, size of particles is larger than 500 nanometer. So in suspension, we can see the particles. In solution, we cannot see the particles even under a powerful ultra microscope. But in a colloidal particles can be seen, actually not particles but the light scattered by them can be seen when they are viewed under a powerful ultra microscope. So this is the state between solution and suspension. They are translucent to light and do not separate on standing. You must have seen the particles of suspension separating or uh, settling at bottom when they are allowed to stand for some time. But colloidal particles do not separate on standing. In colloidal sol, we call it sol. Largest component is called as dispersion medium, as we call it solvent in case of solution. And smaller component means a smaller amount wise. Amount wise, smaller component is called as dispersed phase. So it is a heterogeneous mixture. The examples are butter, jelly, mayonnaise, blood. Actually, blood acts as colloidal sol as well as suspension. Colloidal sol of plasma protein in the form of dispersion medium, and various salts in the form of dispersed phase, and in the form of suspension as blood platelets uh, are suspended in plasma. So antibodies and plasma forms a antibodies and plasma form a colloidal sol, whereas platelets and plasma form a suspension. So these are the examples. In sky, the minute dust particles, water droplets, they form a colloidal suspension, colloidal sol, and they scatter blue light, so the sky appears blue. Now, types of colloids based on physical state. See, they have given a chart in your textbook. When dispersed phase is solid and dispersion medium is also solid, it is called as solid sol. And the examples are colored glasses, gemstones, porcelain, paper, etc. Solid dispersed in liquid, salts and gels. They are paints, cell fluids, gelatin, muddy water, starch solution, etc. in which dispersed phase is solid and dispersion medium is liquid. When dispersed phase is solid and dispersion medium is gas, it is called as aerosol. Aerosol examples: smoke, dust, etc. When dispersed phase is liquid and dispersion medium is solid, it is called as gel. The examples are cheese, butter, jellies, etc. When dispersion medium is liquid and dispersed phase is also liquid, it is called as emulsion. Milk or hair cream are in the form of emulsion. When liquid is dispersed in gas, again it is called as aerosol. Fog, mist, cloud, hairsprays, insecticide sprays, they are aerosols in which dispersed phase is liquid and dispersion medium is gas. When dispersed phase is gas and dispersion medium is solid, that means gas dissolved in solid, it is called as solid sol, and the examples are pumice stone, foam rubber, plaster, etc. And last one is when dispersed phase is gas and dispersion medium is liquid, colloidal sol is called as foam. Froth or whipped cream or soap lather, they are examples of such colloids. There is one more chart of the types of colloids: lyophilic colloids and lyophobic colloids. Lyophilic means dispersion phase loving, and lyophobic means dispersion phase or dispersion medium hating. That means you can call it solvent loving and solvent hating. Liofilic colloids. What are liofilic colloids? They are formed easily by direct mixing. In liophobic colloids, some special methods are to be applied to form them. Liofilic colloids are reversible, liophobic colloids are irreversible. In liofilic colloids, the particles are not easily visible even under ultramicroscope. And here in liophobic colloids, they are easily detected under ultramicroscope. Liofilic colloids are self-stabilized. You don't need to use a stabilizer. But liophobic colloids need a stabilizer because they are unstable. Addition of large amount of electrolyte causes precipitation or coagulation. Coagulation means precipitation of colloids. That means the separation of dispersed phase from dispersion medium. And since liophobic colloids are dispersion medium hating colloids, addition of a small amount of electrolyte causes their precipitation. Viscosity of dispersed phase is much higher than that of dispersion medium. That means here dispersion medium is thinner, whereas in liophobic colloids, viscosity of dispersed phase is nearly the same as that of dispersion medium. In liophylic colloids, surface tension of dispersed phase is lower than surface tension of dispersion medium. And here, surface tension of dispersed phase is nearly the same as that of dispersion medium because their viscosities are also similar. So these are the two types of colloids, liophylic and liophobic. Liophylic colloids means dispersion medium loving colloids, and liophobic colloids are dispersion medium hating colloids. Now let's classify colloids on the basis of molecular size. They are of three types: multimolecular, macromolecular, and associated colloids or micelles. First, multimolecular colloids. They are aggregations of small particles, and particle size is less than 1000 picometer. Particles are held together by van der Waals forces. For example, gold sol or S8 colloidal sulfur. These are the examples of multimolecular colloids. So have you followed what are multimolecular colloids? They are aggregations in a dispersed phase is in the form of aggregation of small particles. Second, macromolecular. Macro means large. So they consist of large particles. Large means polymeric. Dispersed phase is polymeric. There is no aggregation. The molecule or molecules of dispersed phase are very large to be of colloidal dimension. For example, starch, cellulose, proteins, polythene, they are all polymers. So they are large particles. These colloids are called as macromolecular colloids. Third type of colloids are associated colloids or micelles. At low concentration, they behave as normal electrolytes, but in higher concentration, they act as associated colloids. These associated particles are called as micelles. For example, soaps or detergents. You know what is a soap? Soap is sodium salt of higher fatty acid. So the general formula is RCOONA. Now this R part is hydrophobic and COONA part is hydrophilic. When soap is dissolved in water, soap particles arrange themselves in a circular manner, which this circular bigger arrangement is called as micelle. This hydrophobic tail, uh, it it is near this uh, dirt or oily part, and hydrophilic head is at the surface. Hydrophilic head is COONA, and hydrophobic tail is C17H35, like higher alkyl group. Carboxyl group with sodium is hydrophilic. It is water loving. Hydrophilic means water loving, and hydrophobic means water hating. So this dispersion in this dispersion medium of water, Soap forms a stable colloidal mixture. Thus, let's make a chart. Classification of colloids on the basis of molecular size. They are multimolecular, macromolecular, and associated. On the basis of phase affinity or interaction of phases, they are lyophilic or lyophobic. And on the basis of physical state, we have seen the chart. Some of them are solid salts, salts and gels, aerosols, emulsions, foam, etc. Now let's see properties of colloids. We have already seen some general properties. One more property is that they do not diffuse through parchment paper or animal membrane, but uh, they diffuse readily. They readily pass through ordinary filter paper. Now, optical property. This is an interesting property which is also called as Tyndall effect. Tyndall observed that when we pass light in true solution, the path of beam is not visible. But when it is passed through colloidal solution, colloidal dispersion, the path of light is visible. This cone is called as Tyndall cone. You can see that the path of light beam is visible when it is passed through colloidal dispersion. This effect is called as Tyndall effect. It is due to the property of colloidal particles that they scatter light. So this phenomenon of scattering of light by colloidal particles making path of light visible through dispersion is called as Tyndall effect, and that cone is called as Tyndall cone. Of course, there are some conditions to observe Tyndall effect. First condition is that diameter of dispersed particles must not be much smaller than wavelength of light. And second condition is refractive indices of dispersed phase and dispersion medium must differ largely. So these are the two conditions to observe Tyndall effect. What is Tyndall effect? This phenomenon of scattering of light by colloidal particles to make path of light visible through dispersion medium. This is optical property of colloids. Now, importance of Tyndall effect. Tyndall effect is used to determine the number of particles in a colloidal dispersion, and so the size of particles can also be known. And third, to distinguish between colloidal dispersion and true solution.